seemed like they matched what he put in the email of the stuff that you would need to know, together with just some things that I thought would be good practice. So since nobody sent me anything saying, "Oh, would you please go over this?" That would be nobody. So you're just you get what I have to give to you. All right. So this first one says, derive the state diagram for the following Mealy sequential circuit. So what does it mean to be Mealy?
You depend on current inputs and current state.
Yes, so your output depends not just on the state that you're in, but also on the inputs. So it depends directly on the inputs. Usually, a Mealy machine will have one fewer state than a Moore machine, because for a Mealy machine, when you get that final input that gives you the result that you want, you don't have to go to a new state from that. But for a Moore machine, one state is going to represent the final state that gives you the output. Okay, so it has one input B and one output G. And when the input sequence is 0, 1, 0, 1 on 4 consecutive clock cycles, then G is 1 in the cycle in which the sequence is detected. That is, when the last one arrives, otherwise G is 0, and overlapping sequences should be detected. Now, so we've got the sequence 0, 1, 0, 1. So when those are the last 4 inputs, then that would be time that you would get an output of 1. Otherwise, you get an output of 0. Now, one thing that to be aware of, most of the time when I've done these problems, I've done them with the order that I'm saying that these are coming in would be that you would get a 0 and then a 1 and then another 0 and then another 1. And that's the order I've done them. And that's usually the order that when I look at the solutions from the 2 professors that teach the class, that's the way they're talking about it too. But I noticed in the recording that he did just yesterday that there was a different idea behind them, in that you would have to get like a 1 first, and then a 0, and then a 1, and then a 0. And I think that if you have a question like this on the test, it might just be worth asking, which would indicate that it's time to get the output of 1, when I get a 0 or when I get a 1. So the way I'm working this is I'm assuming that you would first get a 0, and then a 1, and then a 0, and then a 1, and then you get the output of 1. So I'm going to say my first state A here, is where I don't have anything that's getting me towards my goal. So that would be nothing. So that could just be like a reset. Or if the only thing you have is a 1, and because you have to start with the 0, then I'm going to call that state A. Now state B would be you're getting started, you've got a 0. State C would be you have a 0, 1. And state D would be you have a 0, 1, 0. And those are all the states I need for a Mealy machine. If I had a Moore machine, I would have to have one more state for 0, 1, 0, 1. But for a Mealy machine, once I get to state D, if I get a 1, then I can go back to some other state. I don't need to have a separate state for that. So here's going to be my state diagram. I'll start with state A, and I'll also have that be the reset. And the way I do these is with every state, I draw the state, and then I say, what happens if I get a 0? What happens if I get a 1? And if you happen to have a problem that has 2 inputs, then you'll go through the 4. Say if I get a 0, 0, a 0, 1, a 1, 0, a 1, 1, what happens? Okay, so if I'm in state A, that means I have nothing. But if I get a 0, then I'll go to state B. And there's two ways you can write this. And I'm going to write it like this. I'm going to write it as B bar, or that B equals 0. You could also just write it as a 0, saying that your input was 0. And the slash is going to be for my output, and my output is 0 because I do not yet have my 4-digit sequence. Now, if I get a 1, then I have gotten nowhere. I don't have anything. So this would be B, as in B equals 1 and 0. Now, if I'm in state B, that means that so far I have a 0. And if I get another 0, then I'm no worse off than I was, but I'm also no better off. I still have a 0. I'm still 1 on my way to my goal, but I haven't advanced any, so I can come back to state B. So that'd be a B bar. If I get a 1, so I had a 0, now I get a 1, now I'm getting a little bit further, and I can move on to state C.
Rebecca, I have
Yeah.
a question. So, I don't know if you watched Vedi's recording. Do you think state A is what he calls got zip?
Yes.
Okay.
Yes. That is what he calls got zip.
Mm-hmm.
Yep. So this one was B bar and 0. So yes, this is the same as got zip. I haven't ever heard anyone else say that, but I mean that's just his terminology, but just means you're not haven't gotten anywhere. Okay, and then B, this was you got a 1, but you still have not gotten to your goal, so it's B. I also see this just written as like 1, 0, with that's your input, that's your output. Now, if I'm in state C, that means I currently have a 0 and a 1. So if I get a 0 here, then I will move on to my next state, which is state D. So it'd be B bar, still don't have an output of 1. If I get a 1, however, so if I have a 0, 1, and then I get a 1, well, I now don't have anything towards my progress, because my progress, I need to have 0, 1, 0, 1, and I have a 1. And so that brings me all the way back to state A. So that would be B/0. Now, if I am at D, that means I have a 0, 1, 0. And if I get a 1, then that means I now will have an output of 1. It also means if I look at what I have here, I have a 0, 1 towards my goal. So I don't have to go all the way back to the beginning. I can go back to B. So if I get a 1, that's a B/1. And if I, wait, that was not B, that would have been C, right? C is 0, 1, yeah. So if I get a 1, I have a 0, 1, so that brings me back here. So it's B and 1. If I get a 0, then that means I have just my first digit here, and that corresponds to state B. So that's B bar slash and 0, because that does not give me the output that I need. Okay, so questions on that one?